Hi everyone, my name is Mara Florina Steiu and I'm a program manager in Azure SQL at Microsoft. And today, together with Alain Dormehl, who's a principal program manager at Microsoft, we are going to discuss some data replication options in Azure SQL and beyond. So let's get started. So for today, we have prepared some interesting discussion topics. So first, we'll very briefly discuss why is data replication relevant, and then we look at some common scenarios that we've seen our clients use data replication for, and what are some of the solutions that they selected. However, it's worth noting that the list of solutions we'll discuss today is in no ways 100% comprehensive. There are so many more first-party and also third-party great data replication solutions that you all have access to. However, we selected some common solutions such as change data capture, SQL Data Sync, change tracking, and transactional replication, and we'll dive a bit deeper into these topics. And lastly, we are going to bring all of these technologies discussed today, and we are going to run a comparison among them to see some pros and cons and so on. Great, so let's continue. So first of all, why is data replication relevant? Data replication is omnipresent in so many business scenarios. For instance, you might have your own company and different branches across the world, and you want to make sure that all the databases in different global regions are staying up to date and synchronized among themselves. So in that case, you might decide to use, for instance, SQL Data Sync or other data replication technologies to achieve that goal. You might have a 911 system at the national level, and you might want to make sure that all your resources and people are effectively and very quickly distributed as needed. So you want to make sure that there is sync and there is shared knowledge among what's happening in different regions of the country. So all your databases and data has to be constantly replicated in near real time. Again, data replication is a great solution. So data replication is really vital in today's world, and this is why we decided to approach this topic for today. So here are some common scenarios for data replication and some popular solutions we've seen customers select for such scenarios. So the first one would be synchronizing distributed applications or workloads and synchronizing globally distributed data, right? So here you might want to synchronize data across databases that store different workloads. For instance, you might have a production database and another database with an analytics workload. And here are some solutions that you might decide to use. Then you might look into business continuity scenarios, which refers to the procedures that enable your business to continue operating even if there is disruption, such as data center outages, application upgrades, regional disasters, and other types of outages. Then you might want to look at scaling out your read-only workloads, and this is helpful because it helps you offload read-only workloads instead of running them on the read-write replica. And this way, some of your read-only workloads can be isolated from read-write workloads and not affect their performance. And lastly, you might want to migrate your data and keep data synchronized when migrating. And a very common scenario for data migrations is many clients we see going from SQL Server on-prem to Azure SQL databases in the cloud. So now we are going to go into a bit of depth for some of the data replication technologies solutions we have selected for today. And we'll start with change data capture, which has been available in SQL Server Azure SQL Managed Instance for some time. And this summer we announced the public preview of change data capture in Azure SQL databases as well. So change data capture allows you to record DML changes such as delete, upsearch, inserts happening in your table. So as you can see in this diagram, you have an OLTP database that has some source tables on it. And in order to use CDC, you must first enable CDC at the database level, and then on each source table that you want to track for DML changes. And once you enable CDC at the level of the source tables, for each enabled table, you will have CDC associated table that gets created on the same database where the changes will be tracked. So the way that happens is that once changes reach a source table that is enabled for CDC, those changes are moved into the transaction log, and from the transaction log, we have the capture process and the cleanup process, which on Azure SQL MI and SQL Server, these are SQL Server agent jobs. And these two jobs take the changes from the transaction log and add them to the CDC capture table. That's for the capture process. And the cleanup process enforces a retention-based cleanup policy of the change table. So it removes expired change tables entries. And lastly, once the data reaches the CDC tables, you have query functions that you can use to consume data from these tables and potentially decide to move the change data to other external environments, run analysis and audit on them, depending on your use case. So this is at a high level how CDC works in Azure SQL Managed Instance and SQL Server. Because in Azure SQL databases, and we've had a public preview recently on Azure SQL DB, the key difference is that there is a CDC scheduler which replaces the SQL Server agent jobs and runs capture and cleanup automatically without any external dependency on reliability and performance. So that is, you can assume that is running on the background. However, if you want to run it on demand at some point, you can still manually execute the stored procedures that you had for scanning and cleanup. So here are some common CDC use cases. You might want to track data changes for audit purposes. You might want to propagate the changes to other downstream subscribers, run analytics on change data, execute ETL operations to move data from the OLTP system to your data lake or data warehouse, and you might decide to use Azure Data Factory, ADF, to take the changes, for instance, from the CDC tables and move them to other environments. And lastly, you might want to run event-based programming for instantaneous responses based on data changes. Here, a great example would be dynamic product pricing. So as you can see, CDC is very helpful in a wide variety of scenarios. So here are some key CDC concepts that are worth understanding before we go into the demo that we prepared for today. So first of all, we have the capture and the cleanup processes. As we discussed, the capture scans the log for new change data, while the cleanup cleans the change tables based on a retention policy. And in Azure SQL database, these are being run automatically on the background by the scheduler, while on MI and SQL Server, they are run by the SQL Server agent as jobs. Moving onwards, we have the change tables, which get created whenever a source table is enabled for CDC. So there you can see all the changes on that source table. We have two DMVs for monitoring CDC that you can see here. We have table valued functions, which allow you to obtain change information and to enumerate changes appearing in change tables over a range. And here you can get all changes, or you can enable such that you get net changes as well. And you will see that soon in our upcoming demo. And lastly, we have the log sequence number, and the commit LSN highlights the changes committed within the same transaction and orders those transactions. So these are some key CDC concepts worth knowing. And in order to enable change data capture in Azure SQL databases, we'll enable first CDC at the database level, and once you do that, there will be 5 CDC artifacts tables that get created on your same database. So it's important to ensure that you have enough space. So it's good to make sure that to check whether you should upgrade your database tier before enabling CDC on your database, because of these additional artifacts that get created on the same database. And once you do that, you enable CDC at the levels of the tables that you want to track. And once that is accomplished, 2 more artifacts get created: the change table associated with every source table, and CDC jobs, where you'll see the jobs parameters. Great. So now let's see a demo of change data capture in Azure SQL databases. So as you can see here, we have a test database which has a very simple one customers table. So we want to enable CDC at the database level, and once we do that, we refresh and we can see the 5 artifacts that I previously mentioned being created in the system table section of the database. It's taking a little bit of time. And you can see they all show up there. So here you can see the list of captured columns, and you can enable CDC on specific columns. We'll see soon. The change tables, the DDL history, the index columns, and LSN time mapping. So this is just, most of these are all empty because you just enable on the database. And now let's see what the customers table has. It has 1 customer. We want to enable CDC at the level of this table. So I have to select the schema, the name of the table, and the role name if I want to control access to the change data. And here, if you see, you can see there is a parameter that allows you to enable supporting net changes. The getting all changes is by default. And you can also select the columns that you want to track. But for us, we'll capture all columns. Here you can see associated CDC tables have been created for the 1 source table that we have. In system tables, you can see there's the new table that just got created. And here you can also see the CDC jobs that just got created. And here are some parameters that we can change and will soon change and we can alter. So for DML changes, I'm inserting a new customer into my table. And you can see that new customer has been automatically added by the CDC Scheduler to the change table very quickly. And however, as I was previously mentioning, I can still run scan manually if I want to, and that still works. So you might want to change the retention for the cleanup policy, which you can do, and we changed it to 30, and now you can see if we go in the jobs again, all those parameters will be, the retention parameters, will be changed to 30. This was a very short demo, and now we are going to disable CDC at the table level and then on the database level. However, you can also directly disable it on the database and it will automatically disable it on all the tables enabled. And here you can see which of your tables are tracked by CDC in case you can't remember. In our case, it's quite easy because just 1. So now, once I found the table enabled, I disable it, and then I run disable on the CDC level. And once I do that, as you can see, now we reload, and all the CDC artifacts will be gone as expected from your source database. Great. So let's move onwards. So the next data replication technology that we want to tackle today is SQL Data Sync, which is available on SQL Server and Azure SQL databases. So SQL Data Sync allows you to synchronize data across Azure SQL, SQL Server on-prem, and SQL on VMs. And the whole concept of SQL Data Sync revolves around the idea of having a sync group, which is comprised of a hub database and one or more member databases. And the hub database has to be a database on Azure SQL DB, while the member databases can be either in the cloud or on SQL Server on-prem. And here are some 4 key properties of a sync group. So it has the sync schema, which specifies the tables that will be synchronized within a database. Then you have the sync direction, which defines whether you want one-way sync or bidirectional. So this means that the sync can happen from member to hub, hub to member, or both. Then you have the sync frequency, which defines how frequently the sync activity will be triggered. So for instance, if you turn on automatic sync in the Azure portal, for instance, you can set up a sync frequency of as little as 30 seconds and as high as 30 days. And that will run sync on that frequency you set. And lastly, you have conflict resolving policy, and this defines when conflict on data modification occurs, which change needs to be preserved. So either member wins or hub wins. And if you select hub wins, the changes in the hub always override the changes in the member. While if you select member wins as expected, the changes in the member will override the changes in the hub. And if there is more than one member, the final value depends on which member syncs first. And lastly, we have a conflict, that we already went through the conflict resolving policy. And now we have the sync agent. And basically when the SQL Data Sync service communicates with the agent, it does so using encrypted connection and a unique token or agent key. And you just need a sync agent to communicate with member databases that might be on-prem, right? Your member databases can either be on-prem or on Azure SQL databases. And the SQL Server databases authenticate the agent using the connection string and the agent key. And this design provides a high level of security for your data. And we announced the public preview of Private Link. So basically, Private Link allows you to connect, so the connection between the sync service and the member databases and the hub databases to be done through a service managed private endpoint, so such that you have secure connection. And you have to manually approve the private endpoint connection. So when you set up a sync group, you have to approve the private endpoint connection between the sync service and the member databases and between the sync service and the hub databases. So manual approval is necessary as of now. And another thing to be aware of is that the member and hub databases must be hosted in Azure in the same cloud type. So for instance, both in the public cloud or both in the government cloud. And some common use cases that we saw SQL Data Sync being used for is, for instance, hybrid data synchronization. So keep data synchronized between your databases in SQL Server and Azure SQL Database to enable hybrid applications. And this might appeal to you in case you're considering moving to the cloud and would like to put some of your application in Azure. Then we have distributed applications. So these allow you to synchronize different workloads across different databases. For example, if you have a large production database, but you also need to run reporting or analytics workload on this data, it is helpful to have a second database for this additional workload, and This approach minimizes the performance impact on your production workload. So you can use Sync to keep these two databases synchronized. And lastly, globally distributed applications. If you want to ensure databases around the world are synchronized, and we'll do a demo to show you how that would work. So now in the demo, we are going to synchronize two Azure SQL databases across the US and Asia. So as you can see, I have a hub database in the US, which has a fruits inventory, and I have 4 items in my inventory. I'm a business having different branches, one in US and this one in Asia. This is a database, a member database in Asia, and as you can see, we don't have the same inventory synchronized between hub and member. So we want to create a sync group to make sure the databases and inventories are in sync. So I create a US to Asia sync group and create a new database for the sync group. This is a metadata database, and this sync database has to be in the same region as your hub database, which, as you remember, is in the US, East US. So I set it up as a basic database, and I want automatic sync every 2 seconds to be triggered with a hub win conflict resolution. And I want to use private link as well to connect to the hub database. Right now we're still at the hub database when we create the sync group. So the sync group is creating right now. And as you can see, manual approval of private endpoint connection is required. So I have to go and approve the connection to the hub. So once the private endpoint connection is approved, I can continue and add the member databases to the sync group. And here I have to write the username and password credentials for the hub database, which we just added. And now I want to add the member database. So I'm going to select the member database, the Asia from the Asia test server. And I selected the necessary database. I do bidirectional sync, and I have to log in with the server credentials once again. And again, I have to use private link to connect the member to the sync to have a secure connection. And I have to go on the level of the server, the Asia server, to approve the private endpoint connection manually. So this is another way you can approve. So I go at the server level, I look on the left-hand blade, and I find the private endpoint connections, and this new one will be pending. So I have to manually approve it before I can add a member database to the sync group. Great. So I did that, and moving onwards, I configured the sync operation. So here I select each database from the group, and I refresh schema and select which tables should be added to the sync. In our case, we only have one table on each side, the inventory table, so we'll select that one. And we'll do the same on the member database side. Refresh schema and select the corresponding table. And as you can see, here I'm within the sync group. I have 2 databases and the table that is being synchronized. And now I'm going to actually run the sync and in the query editor to add some items and see how they get synced between the 2 global databases. So here I'm on the member database, I log in there as well. as I'll be running some queries on each of the database to include some items. So first, you remember that, so right now we also have some artifacts created on your source database similar to change data capture. However, unlike change data capture, sync works through triggers, while change data capture takes changes directly from the log. So as you can see, now in the Asia, we have the melon, which was missing initially. Initially, we only had the melon, which was in the US and not in Asia. But so you can see both of the inventories are in sync because sync was triggered and it's being triggered every 2 seconds. So now I'm going to insert in the fruits inventory in Asia on the member side as well to see how it gets synced and replicated on the hub database. Because remember, we said bidirectional replication. Here I made a small mistake. So bidirectional replication, so we had it go from hub to member, and now we want it to go from member to hub as well. So we inserted the dragon fruit in the Asia database, and let's go on the hub database in the US. And it's still not there. So even though sync gets triggered every 2 seconds, it takes some additional latency for the data to actually get triggered. That's an important thing to mention. So sync does not do near real-time replication. But let's go back. It should have had enough time for this one item. And you can see here, if you go back, for some reason it stopped. Yes, so here if you went back, you could have seen that the item got eventually replicated on the Asia side. Just a second. So we had a small technical error. So here you can see on the hub database, the dragon fruit got replicated from the member back to hub. So we have successfully set bidirectional replication between the hub database in the US and the member in Asia. Some considerations for SQL Data Sync. You need, as you might have noticed, you need a primary key for sync to work. So you need the primary key on all the tables that you want to include in the sync group. And if you have a workload that involves frequent changes of primary keys, you might have some issues using SQL Data Sync. So that's something to be aware of. So let's move onwards. So we have change tracking as well, which is currently available in SQL Server and Azure SQL databases. So change tracking allows you to record the rows in a table that were changed without capturing the actual data that was changed. So change tracking helps you respond to the question, has data been changed? Not necessarily what were the data changes as well, not necessarily going into the historical data changes as well, in which case you would want to use change data capture, right? So yes, it records that rows in a table were changed without capturing the actual data that was changed. And each table that is enabled for change tracking has an internal on-disk table, which is used by the change tracking functions to determine the change version and the rows that have changed since a particular version. And you have auto cleanup, which scans all the user databases to identify the change tracking enabled databases, and based on the retention period setting of the database, each internal on-disk table is purged of expired records. And for the query functions, for the change tracking query functions, basically this helps supply the details of the changes in an easily consumed relational format. And some examples of functions that return information about the changes might be the change table function, which returns tracking information for all changes to a table that have occurred since a specified version. We have our auto cleanup as well, which we just discussed. And lastly, we have the change tracking current version. So every time you access a table, you can ask for the version number active at that moment. And you must keep that version number safely stored somewhere so that next time you try to access the table again, you can also ask Azure SQL to only get the change data starting from that version number and onwards. So here in this screenshot, you can see that based on the caller ID, you can see which change operation, which DML change has occurred on that item. So insert, update, or delete. And as I was previously mentioning, change tracking and change data capture are similar but also different in many ways. So while change tracking shows you which rows have been inserted, updated, or deleted, and you can see the net changes based on the version number. For CDC, you get DML historical data recorded in the change table. So you can actually see that historical data, and then you can take the data with query functions, consume it, and send it to other external environments. But depending on your work, on your scenario, you might just want to know, has data been changed and what changes have occurred on this data, in which case change tracking would be enough, and it actually has less overhead than change data capture, right? Because for instance, for CDC, you saw there are all those artifacts created on your source database, and it's worth having some comparison between the two to realize, okay, if change tracking is enough, then it makes no sense to use CDC as well. And both of them have to be enabled at database and the table level. However, for change data capture, each enabled source table has a corresponding system table, as we've seen in the same database, while on change tracking, each enabled source table has a corresponding on-disk table. And both change tracking and change data capture can be enabled on the same database, so you can have them running in parallel and no special considerations are necessarily required. So here you can see how to enable change tracking. You have to enable it at the database level, and you have the change retention and auto cleanup parameters. Then you have the change tracking being enabled at the table level. We have that through an alter statement, and you can track columns updated on. So column tracking can enable an application to sync only those columns that were updated, and this can greatly improve efficiency and performance. However, because maintaining column tracking info adds some extra storage overhead, this option is set to off by default. So you have to manually set it to on when you enable change tracking on the table level. Then you can, here, this is what you can run: the change tracking database, change tracking tables to determine which databases or tables have change tracking enabled. And then you have the function change table, which we just discussed about, that allows you to get the change tracking current version. Moving onwards, we will also discuss transactional replication, which can be used on SQL Server, Azure SQL databases, and Azure SQL managed instance. However, for Azure SQL databases, you can only use those as push subscribers for transactional replication. So transactional replication allows you to propagate data changes to a subscriber in near real time. So as you can see here, you have three key components to transactional replication. You have the SQL Server snapshot agent, the log reader agent, and the distribution agent. So the snapshot agent creates the snapshot files. Then you have the log reader agents that monitors each database with transactional replication and copies committed transactions from the transaction log, as you can see, the transaction log on the publisher, into the distribution database as shown in this diagram. And lastly, afterwards, you have the distribution agent, which takes the initial snapshot files from the snapshot folder and the transaction from the distribution DB to subscriber DB, as seen here. And the distribution agent can run continuously or at scheduled interval. So some of the benefits to choosing transactional replication would be low latency from going from publisher to subscriber, and also the fact that the publisher can have a very high volume of insert, update, and delete activity. However, there are also some limitations. So as I was mentioning, databases in Azure SQL can only be push subscribers. The subscriber must contain tables with same schema as tables in the publisher. The replicated tables must have a primary key. And some considerations would be that transactional replication can be enabled from the SQL Server Management Studio or through T-SQL, and there's no Azure portal interface for transactional replication. One last thing is that for standard transactional replication, the data at the subscriber is read-only, so that's important to know. However, there is transactional replication with updatable subscriptions, which allows updating rows on the subscriber. And these would be some of these considerations documented as well. Right, the near real time, the high volume of DML activity, the read-only on subscriber for standard replication, and the same schema requirement. So we have discussed several replication technologies such as SQL Data Sync, change data capture, change tracking, transactional replication, and did some demos as well. I hope this has been helpful for you. I just wanted to copy again this slide to refresh the common scenarios for replication and the popular solutions. And as I was previously mentioning, this is in no way the most comprehensive list you can find. There are many other first-party, third-party solutions that you might want to use, and please let us know if we can help in any ways to ensure you get to choose the best solutions for your specific scenario and workloads. Thank you. Now we are ready to take the Q&A questions and respond any additional questions in the chat. Thanks, everyone.